Hello and welcome back to the video lessons for Outcome 7A. Today we're on lesson number 4, where we are going to be using our technology, our graphing calculators, to approximate data that is given to us as a set of data points. From that, we are going to interpolate and extrapolate data from those equations and functions that we graph. So again, our goal is to determine today, we're going to look at simply linear functions that best fit whatever data we are given. And then we're going to use that function to solve problems later on. Again, using things called interpolation and extrapolation. So let's start with some definitions. The first thing that we have is a scatter plot. A scatter plot is very much like the graphs that you do in science. It's basically just a set of points that are on a grid, where you look at the trend. Is it going up? Is it going down? Is it curving? Just a bunch of dots on a grid. When those dots, so for example, if you have a bunch of dots on a grid, and they look linear, a line of best fit is whatever line that best approximates that trend. A regression function is something that your calculator will do. It will basically tell you what is this function. F of x equals what? The calculator will tell you what that function is. So it's super handy when you're given a data set. So these two words, interpolation and extrapolation, should be somewhat familiar to you from grade 9. Let's just review them. Interpolation is when you estimate within the domain. I always think interpolation is inside the data that I have. When I have to estimate outside of the domain, that is called extrapolation. I always think about it as having to extend the graph. So inside the graph, inside the data is interpolation. Anytime when I have to extend the data, extend the graph, then it's extrapolation. When we graph, just a reminder that the independent variable is the variable that is being manipulated. The dependent variable is the variable that is being observed. Independent is always on the x, dependent goes on the y. So at this point, I would pause the video and I would go grab a graphing calculator, because today we're going to learn another thing that we can do on them. Alright, so turn those calculators on and let's work through this example. It says the 1 hour record is the farthest distance traveled by bicycle in 1 hour. The table below shows the world record distances and the dates they were accomplished. So generally when you have these, the first is going to go in x, the second is going to go in y. We are going to use technology to create a scatter plot. So let's learn how to do that. So it says the first thing you want to do is create a new document. This time we want to add a list and spreadsheet, the fourth one down. And now you're going to see something that looks like an Excel spreadsheet. Right. So now we are going to enter in our data. So the first thing you need to know is that it will not work if you do not put a title in there. You can make your title whatever you want, X and Y, or in this case it's year and distance. So I'm just going to type year. There. I'm going to move it over. I'm going to type distance. Actually, I'm just going to type DIS. Type whatever you want. You have to have titles to make it work. Now I'm going to move it to where I have my first row where it says 1, and I'm going to start entering in that data. So 1996, 1998, and I'm just entering that in. I'm just going to pause it and quickly enter it. So I paused the video, but you can see that I've entered in all of my y values. And I just noticed now that I typed y right here with 2 y's. That's okay, it doesn't really matter. Now I'm going to move it over. And I am going to start typing in my y values. So again, the first one is 78.04. Next one is 79.14. And again, I'm just going to pause the video just to save some time, and I'm going to finish typing this all up, as you should too. Alright, now you can see that I have now finished my table. The next thing that we need to do, it tells us that we need to highlight our cells. So what you want to do is you want to just hit the up arrow, and you want to do it so it goes all the way up until it highlights the whole thing. Then you hit the shift, and you want to hold that shift arrow down as you hit the over button, and it's going to highlight the whole thing. From there, we select menu, and then with that data, we hit 3. We want to make a quick graph, 9. And now you can see that I've made a scatter plot. Now, it's not very fun to work on 2 screens like that. We'd like to make it onto 1 screen. So to do that, we have to hit Control and then 6. Now you can see that I have a 1.1 and a 1.2 page. If I hit Control and then the arrow button over, I will go to page 1.2, and there is my scatter plot. Now the scatter plot on its own does show us that it looks like a line, and it looks like a nice positive line, but we would like to know what the function is. So we are going to go to Menu. We're going to go to Analyze, which is the 4th one down, and then we are going to hit Regression. Now we are going to be doing this lots through many different functions. So in this case it looks linear. I am going to hit Show Linear, which was the first one or the second one, doesn't matter, they're both going to give you the same answer. And it gives me the function y equals 0.85848x plus a negative 1.63.17. Now sometimes you won't be able to see it all, so you'll see how I'm moving my mouse and there's a little hand. I hold the little button down and it will pick it up, and then I can move it. And there it is. I can move that around so I can see it all the way through. Now that we have the equation, we can now find some estimates. So the first one says, interpolate the data to figure out what would happen in the year 2006. The first option you can do is to use that equation and enter it in. So this is an option if you like that. In this course, we are generally going to be using the trace button on our calculator, but you are more than welcome to sub in and find answers that way if you'd rather. So we're going to focus on option 2, which is the trace. So now I hit Menu, Analyze, and now I want to do a graph trace, which is A. And now you'll see I have a little cursor, a little X, on my line that I can move right or left. So I am literally going to trace it until I get to 2006 on my X. Right? So what I'm looking for, because 2006 was a year, if I'm thinking of my point as an X and a Y, my X is 2006. I have no idea what that Y is. So I'm going to try to get as close to 2006 as I can. Every calculator is a little bit different. Because we're estimating, answers won't be perfect. But you want to get there as close as you can. So I'm at 2004, 5. Well, here's 2006.2. It's 86.548. Over here it's pretty close as well. 2005.97, I get 86.35. So either of those is a pretty good guess. So I would say 86.35, which is pretty close to the person who did this previously on their calculator and got 86.399. And if I use the line of best fit, you get 86.40. Pretty good for an estimate. So that's interpolation because 2006 fell within the data that we had. Let's try an extrapolation example. Sorry, not yet. The actual world record distance is 2006 is 85.99. compared that to my estimate. So there is a difference. 85.99, subtract what we got, which was 86.35. We are off a little bit. 85.99 subtract 86.35 is a negative 0.36. So I'm off by 0.36. Why is there a difference? It's because it's an estimate. Estimates are not always accurate. I made an assumption that it would be linear between the two values where 2006 fell, and it might not be. And I definitely can't spell accurate. You get what I'm trying to say. Okay? So anytime you have an estimate, it might not be great. Now the next one, it says we need to extrapolate, and we want to figure out what year did we get a distance of 94.60. So again, you have an option of subbing in. Now if you have a point xy, 94.60 is a y value. I need to figure out the x. And so you would plug the 94.60 in for y and then solve. But again, in this course, we are going to focus on using the trace. So I still have my trace on my calculator. I am now going to move it up so I get as close to 94.6 as I can. So again, sometimes when you extrapolate, it's really frustrating because you got to move a little bit farther. Like right now, I'm only on 86. I got to go all the way to 94. It's going to take me some time. Here's 94.0. I get 2014.98. So it looks like it's pretty close to 2015, which is what they got. So that's how you use a trace to do an estimate. So we can do one more together, but if you're feeling comfortable, by all means, you can stop the video now and start the practice 4. I am again going to do one more example. So sometimes when you are interpolating or extrapolating, you might need to round if they're discrete. So if we're talking about t-shirts, you're not going to have 4.25 t-shirts, you'd round it up to 5. Just a heads up. So here's the next example that I want to do. So again, when you don't know how to restart, just hit home. You want to make a new document. You don't want to save. No, we want to make a list in a spreadsheet. And there we go. You got to label these. We'll make this one altitude, A, LT. Second one is air pressure. We'll put that as pressure. PRESS. And now I'm going to start entering in these data. So I'm just going to pause it as I enter. Again, I encourage you to enter it in as I go. Alright, so now we have our list done. I need to highlight it all. So again, I use the up arrow. I go all the way up. I hit shift. I hit over. There it is. I hit control and I hit 6. Oh, sorry, I'm off. I need to make a quick graph. I need to re-enter that, make it a 0. My apologies, right? Sometimes we make mistakes. Right, I highlight it, I hit shift, I move it over, I hit menu. I want to do a quick graph, so 3 for my data, 9 for a quick graph. There's my graph. Then I hit control and I hit 6. Now I have 2 pages. I hit control and arrow to get my page. And it looks like a nice line, decreasing this time, but now we have a scatter plot. Again, we want to make a regression, so I go to menu, I go to analyze, and I make a regression. It's linear, so I pick linear, and there's my regression line. I want to make sure that I'm reading it all, so I'm going to move it, and that's what I'm going to enter up on the smartboard. My regression line is y equals negative 10.3429x plus 95.5238. So here right after the regression line, y equals negative 10.3429x plus 95.5238. Right, C says now what will the air pressure be at an altitude of 6? So altitude is on my x. So in my point, I know that the x is going to be 6. I have no idea what it is going to be. So now I need to do a trace to find that out. And if I look at D, I'm figuring out what is the altitude if the pressure is 18.5 kilopascals. So that is on the y. So I do not know x, but I know the y is 18.5. So I need to go menu. I need to go to analyze, and I want to do a graph trace. And so I look at where I am, and I need to trace both of those values. So I'm going to trace my 6 first. So I'm just going to simply move it to get my x as close to 6 as I can. At 5.8, 5.9, 6.03. That's a pretty good guess. I got 33.1219. So that will be my guess. So in this blank, I will write 33.1219, and that is in kilopascals. Now it's my time to estimate for the y being 18.5. I'm at 33, so I need to move it a whole lot more. So I need to move it till I get to 18. Oops. There's 17.5. Here's 18.4. I get 7.45, so that's going to be my guess. 7.45. And that is in kilometers. So that is the end of now video lesson 4. Time to try some on practice 4.